Hello and welcome. Today we will give the briefing of the first lecture. It is about the microprocessors. The outline of this lecture will be as follows. First, we will follow the evolution of the microprocessor technology, define the instruction set architecture and its role, and lastly, give you the components of the microprocessor and how it works. So, the processors first appeared in 1971. The first processor was merely a calculator, 4-bit calculator. Now we have a powerful processors with over 16 billion transistors, 8 to 18 cores to 128 cores, and with the power of calculation for 4 to 5 gigahertz. That's something great. According to Gordon Morlow, the number of integrated devices in a single piece of silicon doubles roughly every 18 to 24 months. Well, this is the famous Moore law. So the microprocessors are instruction set processors, which mean ISP. It executes instruction from predefined instruction sets. So the instruction sets are known as the ISA, okay? They are the programs that run on the microprocessors. So, an ISA defines or specifies a behavior. It is a behavioral description, which means that it describes how is this thing supposed to work, while the ISP is the implementation of this design, which means the structural description. The ISA defines a set of instructions called the assembly language. So, the microprocessor design process is as follows. So, you have to first start with a specification. Then you do the synthesis, okay? You attempt to find an implementation. Then you find the implementation. You analyze this implementation, which means that you examine it. You see how correct and effective this implementation is. And then if you need to redo the specification, you redo it, okay? So this is the process or the design process of a microprocessor. So what is the ISA role? It represents the contract between the software and the hardware, okay? It serves as the specification of a microprocessor, and it defines an interface that separates what is done statically at the compile time versus what is done dynamically at the runtime, okay? So, at the compiling time, we are talking about software, so that is the static part. And when we are running the software, the input, the output, etc. in a dynamic manner directly on the hardware, that is the runtime, okay? That's the thing that we do at the runtime. So we write software, it's a piece of code, it's static, and the hardware, when we are executing it, we are in the runtime, so it is dynamic. And the layer in between, that is the role of the ISA, okay? It's the dynamic static interface. Now we talk about the microprocessor's components. So what does a microprocessor contain and how it does work? So a microprocessor mainly contains a calculation unit, a control unit, a cache memory, and registers. That are the main components, not the only one, but the main components. So the calculation unit contains arithmetic and logic units, floating point units, and multimedia units, or the ones that do the vectorial calculation. The floating point does the real number calculations type, and the arithmetic and logic does the arithmetic calculations and the logic calculation. So, the control units, or the CU, it coordinates the processor's components so as to execute a set of instructions, okay? So, it's the one that controls everything. The CU components are an IP, or an instruction pointer, an ER, which is the instruction register, a decoder, a clock, and the sequencer. What's in gray, it's the French name of these components, okay, for those who like to know the French terminology. The CU also contains an address register, which contains the address of the memory word, and the memory register, which contains the memory word itself. We will explain how does it work. So the processor, here is the processor with all its components, the control unit, the calculation units, and the address register and memory register. Okay, we give an example of executing one operand instruction. So it has two cycles. The first one is the search cycle. The search cycle fetch the instruction from the instruction pointer to the address registry, which will fetch it from the memory and put it in the memory register. Once the instruction is in the memory register, it gets copied into the instruction register and gets decoded into the decoder. So the instruction is, as we said before, one operand instruction. So it has an operation code and operand. So the operand is sent to the address registry to be fetched later from the memory, and the operation code is sent to the sequencer. As you said, as you notice, the sequencer is attached to a clock which is advancing, and the next instruction is then sent to the instruction pointer, or the address of the next instruction is sent to the instruction pointer, and we go to the execution cycle directly now. So the operand is, as I said before, will be fetched later from the memory. In the execution cycle, it is fetched from the memory, put into the memory register, and then from the memory register it is sent to the accumulator. The calculation units, ALU units, does the calculation when it receives the code of the operation to be executed from the sequencer. Once it receives it, the execution is. Of course, if the instruction was not one operand instruction, for example, it was jump instruction or write instruction, the result will be different and the process will be different, but only the execution cycle will be different. As I said before, clocks are very important. So the clock defines the basic cycle used to synchronize each step of the research and execution cycle. The CPU cycle is the minimum time used to execute an instruction, including both of its phases, which are the research or the search and execution. The sequencer can be wired or hardware or firmware, which is microprogrammed. The wired or hardware sequencer is faster and harder to make. Every instruction is represented by a set of connected logical gates. It is used in devices that are based on RISC architecture. The firmware sequencer or microprogrammed sequencer is easier to make and more flexible. The micro instructions are saved in a ROM. Okay, in a read-only memory. It is used in devices that are based on CISC architecture. We'll come to this. So the curiosity, I want you for the next session to search about the RISC and the CISC technology. So I give you a hint. A RISC is a reduced sets, instruction set computer, and the CISC is a complex instruction set computer. So I want you to search about both of these and to give me a briefing about the important references. Both of these lectures and book are very useful to answer the curiosities or the question that I gave you. Thank you so much.